I'm Christian Bonten. I'm father of 2 children, etc., etc. And yeah, when my 2 daughters became engineers, I'm glad. No, I studied engineering in Aachen and later specialized in plastics engineering. Then I went to BASF, chemical company. Then I changed. I moved to a small and mid-sized company into the managing. I was becoming managing board member. And later, 15 years ago, the people asked me to join University of Stuttgart as a professor and running the Institute of Plastics Engineering, Institut für Kunststofftechnik. It's much lighter. It's much lighter than the other materials. Okay, paper is light as well. So okay, so we have to differ. I mean, it's much lighter than glass. It's much lighter than metal. But it has the same density and lightness like paper, but paper is not as tight and not watertight. So there are lots of differences. Of course, metal packaging can do a lot, and glass packaging can do that, and paper. Each in its wherever you need it, you find the advantages and disadvantages, but in most cases we have a lot of advantages fulfilled by plastics, and in addition, it's much lighter and less energy consuming. The whole process of producing a piece of packaging is protection. Let's say packaging protection per price is the best in plastics. Yeah, shelf life is a thing. You can have a very thin packaging plastics that allows a long shelf life and good food safety. And in other materials, they might protect as well, but you need much more material and much more maybe energy again to produce this packaging. I always tell my students, please find a study that shows that the final product, be it a packaging or something else, being a packaging product, the product made out of plastics loses the competition. And it's always the case in 98% of these life cycle analysis, you find the plastic solution best. That means using less nature for being the product. Yes, we know that in Europe, or let's say all over in the world, we are very lazy in doing recycling with plastics. I don't know why this is the case. In the German-speaking countries, we are quite good in collecting rates and then also in the recycling rates. So it is possible to do that. And I know the new legislation forces us to reach 63%, while the other materials are much higher, above 90%. So I think it's a question of collection waste, and we can do a lot of recycling and even more than we do today. Yes, recycling works. We have material recycling, we have chemical recycling, and we can go even more backwards to the carbon atom with pyrolysis and gasification. And from my point of view as an engineer, I'm working with material recycling, which is where we melt the material again, which can only be done with thermoplastics. I understand that the other groups of plastics like thermosets and elastomers are not recyclable in this way. So I would focus on recycling thermoplastics, and there we haven't used our full potential yet. We can do much more. And especially with PET recycling, we have shown that we can reach the previous values of properties. Yes, definitely we can increase. This is smart recycling. We can do a lot of already now, but with smart recycling, like design for recycling, we can reach much further values, higher values for recycling. For instance, at the moment we combine a lot of materials in order to, like a film, we have a 3 or 5 layers film, which is really good, but we cannot separate these film, these layers anymore afterwards. So we have to rethink and redesign. First, I think in the news sometimes you listen about microplastics everywhere, and then I'm reading through it, and then sometimes I listen. This is not microplastics. This is chemicals which they find in nature, and these chemicals might be used for making plastics or polymers. And so sometimes I'm wondering what they are talking about. Is this really plastics or not? But if we're considering having microbeads, microplastic, that is so small, or is getting so small that even cells can take up through the membrane, can tell up these little pieces, then I understood from biologists that then the cell might be able to use the polymer as an energy source, so to digest it and use it for growing. So at the moment, I'm not sure if everything what we read is really is focusing really on having the right focus on microbeads or microplastics. First, I would like to distinguish between the two, because biodegradable plastic is not the same. I mean, has another meaning, means we want the plastics become nature, they will turn to nature again. This is biodegradability, and this is the benefit is largest, I would say, for products or applications that inevitably land in nature. So there are some applications that need biodegradable plastics, and even technical applications for a certain time can use that. I mean, we have to, of course, understand that biodegradability is in a certain way breaks down the molecules after a while, and then we cannot use it anymore. Of course, we need to understand that. Talk about bio-based plastics, which are, let's say, the origin is coming from nature, so it's not made for becoming nature. So in this case, the origin comes from nature and not from oil, gas, or coal. And so the benefit for the society is that we don't use oil, that we do not use fossil resources. And if you burn these materials, the CO2 coming from the flame is a new CO2. It's taken up from nature just a few months before. So this is the CO2-free emissions. This is what we call closed loop, etc. So bio-based plastics might have, are definitely good because we don't use fossil resources, but in the final product, they might have the same properties as ordinary plastics, fossil-based plastics. For instance, renewable energies need plastics, wine water blades, etc. We need even stronger material. For fuel cell membranes, we need the right material. We need, for fuel cells, the stacks, the so-called bipolar plates need to be out of plastic in the future, because we want to use these lightweight fuel cells for our cars in the future. Then, like bioplastics, of course, we need, in order to become climate neutral in 2050 in all of Europe, we need to reduce our fossil raw materials demand. So we need to focus on recycling, and what we cannot recycle needs to be filled up with bio-based materials. So I think these are main focus areas, including increasing productivity by means of artificial intelligence. But first, I need to tell you that cheap material doesn't work. I mean, this is not true, because I tell my students, look, a good steel you need for building houses and machinery costs more. Less. Costs a little less. A good polyamide costs more. So it's not a cheap material. It's usually the process, because we need so few energy, which makes the LCA so good. We need much less energy to produce a product. So that's the product is cheaper, might be cheaper and lighter and. But the material per kg or per liter is often more expensive. But coming to your the second part of the question, indispensable, yes. Fuel cell membranes and rotor blades, and so we have a few applications where you cannot work without plastics, and in other cases where plastics play a very good role and win the race, it's usually because of lightweight and few energy consumption, etc. Few energy consumption of the process itself. The LCA wins the race. I fully understand that if citizens, or let's say, this is a human and a societal problem that plastics end up as litter in our environment. This is not a question of the plastic itself. So, of course, I would encourage politicians to encourage the society to collect the waste and bring it back. Because if we have it back, we can recycle it, or if we don't want to recycle it, we can do wonderful other things with it, but it doesn't have to end up in the environment. That's an issue that should be, I mean, we need support, policy support. Yeah, I would say in the last years they have developed. So I'm doing a lot of expert, how can I say, I'm very often in Brussels, and they also in Berlin, and they're asking me a lot of questions. That's good. And I not only the NGOs, but also politics. And I learned to know very wonderful people. And over the years, I saw that they changed step by step the mind. So they're important as long as they're open for discussions. And so I love NGOs, and I know very intelligent people there. But I also know that sometimes they have to sell their brand and collect their money. And so sometimes they are not fair. But in general, of course, I'm a friend of NGOs. So my father was a chemist, and he was working with polymers and plastics, and I was always more on the let's say practical side. So let's say engineering and plastics. So somehow I decided to study engineering and then later specialize in plastics engineering. I never regretted that.